Hello everyone, welcome to Almighty Tricks. Today we'll be solving one question from LeetCode, that is number of enclaves. So the input will given like n cross n matrix, binary matrix. So it will be containing 0 and 1. So here 0 is representing C and 1 is representing land. Okay. So and also we can move in 4 direction. Okay, the important part is we can move in 4 direction. So we need to return the number of land cells in grid for which we cannot walk up the boundary of the grid in any number of moves. Okay, so let's understand what this question is saying. Okay, so the question is saying, so we can have an n cross m matrix, we can have n cross m matrix, and C is representing 0 is representing sea or water, and 1 is representing land, and we can move in 4 direction. We can move top, bottom, left and right direction. Okay, and these are the coordinates. Okay, and let's say let's take this example. So we have this matrix, let's say 0 1 2 3 0 1 2 3. Okay, so we need to find number of ones. So what we need to find? Number of one which cannot walk off the boundary. So it means say let's take this example and say I am present here. Okay, so I'll check in 4 direction, I'll check in top direction, I'll check in left direction, I'll check in right direction, and also I check in bottom direction. So in the top direction I cannot go because it is a C, right? I cannot move. In the left direction I cannot move, in right direction I cannot move, but in bottom direction I can move, but it is moving from the grid, so it is walk up from the boundary, so we cannot consider this one. Let's take this grid. Okay, let's take this grid. Okay, so this grid, can I move to top? No, I cannot go because it is water. Can I go to left? No, I cannot go, it is water. Can I go to bottom? No, I cannot go, it is water. Okay, can I go to right? Yes, I can go. Okay, I can go to right. Here is land is present. So from here also I need to ask, can I go to top? No, I cannot go. Can I go to right? No, I cannot go because it is water. Can I go to left? No, I cannot go because I already visited this uh, cell. Okay, now can I go to bottom? Yes, I can go to bottom. Okay, so here again I need to ask whether I can go move to 4 direction or not. Okay, so if you observe here, these three ones we cannot go outside of the boundary. So these three, if I tell you these three ones, we cannot go outside this boundary. Okay, outside this grid. Okay, so the answer will be 3. Here the answer will be 3. 3 is the answer. Okay, let's understand another example. Okay, so now let's take this example. Let's say I am present here, so I need to check whether I can go in 4 direction or not. Once I'm coming to this button direction, then I'm moving from this grid. Okay, so I cannot consider this one. Let's check from here. Okay, so can I go to here? No, I cannot go. I can move to here, I can move to here, then I can move to here. Now observe, from here I can move to here. Okay, so out of the grid, so here also I cannot consider all these things. So the answer will be 0 here, because none of the one is not satisfying this condition. Okay, so here answer is 0. Okay, now understand how we can solve this question. So to solve this question, we can use BFS or DFS, as it is a graph problem. We can use BFS or DFS. Okay, so let's understand. So I'll be explaining about the BFS, and but I'll be coding in both the approach, BFS and DFS as well. Okay, so let's understand the steps. So the first step will be, I need to have visited array. of size n cross m. Okay, why I need that? Because I need to track the cell whether I have visited or not. So that for that purpose I am using this visited array. Okay, the second what I need to do. So if you observe one thing, whatever the boundary once, if any one is present in the boundary, let's say this is the boundary, right? This is the boundary, this one, these are the boundary, right? Connected to boundary. Okay, so if any one present in this boundary, so what I'll do, so it means what? It is not possible because we can directly come out of the grid. So we can mark it as true, right? So what I'll do, I'll go through uh, topmost row. Okay, then topmost, sorry, bottommost row, leftmost column, and rightmost column. Okay, then I'll check if that cell is 1, then I'll mark it as true. I'll mark it as visited array. I'll mark it as true for that cell, and also I'll push into queue. Okay, I'll push this row and column into that queue. Okay, so this is the second step. The start step, what I'll do, I'll traverse this queue, traverse the queue, and and check with 4 directions. The directions are like 0 1, 0 minus 1, then 1 0, then minus 1 0. So these 4 directions we need to check for from that cell. Okay, then at the end, in the fourth step, what I'll do, I'll loop through the grid, the input grid. Okay, so, and calculate the answer. Okay, calculate the answer. So this is the approach. These are the steps. Let's get into the code, then we can easily understand. So first of all, what I did, I am maintaining n and m and a visited array I have created. Okay, boolean type, and here I am updating the n and m value, and visited array I have created with n cross m, and I have created queue. Okay, and here actually I am going through topmost row and bottommost row, leftmost column and rightmost column. So if you check this one, so this is the, like, I equals to 0 means, it means topmost row. J equals to 0 means leftmost column. Similarly, this thing also. Okay, so then if it is 1, that cell is 1, then I'll push into this queue. Okay, and I mark it as that cell is true. Okay, this is the first and second step. Okay, now in the third step, what I'm doing, I'm looping through this queue till it is empty. Okay, then I am pulling this element, pulling this first element. Okay, and I'm maintaining one pair here. If you see, this is the class. Okay, so it is maintaining row and column. Okay, by which I can easily get the current row and current column. Okay, and here I am going through the 4 direction, 1 0 minus 1 0 0 1 0 minus 1. Okay, and I need to look through in 4 direction, right? So I am going till 4. Okay, and I have create, and I'll get the new row and column from this coordinates, right? Using this coordinate I'll get this. Okay, then here actually I'm checking the boundary. Let's say n is 5. Okay, n is 5, and if I am adding something, then it will extend the boundary, right? So it will give index not found exception. Okay, so to avoid that one, we are maintaining this. Okay, now here I need to check whether this cell is visited or not. If it is visited, then I no need to visit again. Okay, if it is false, if it is not yet visited, and if it is one, so if it is one means what, it is a land, right? So we no need to check about the zero. So if it is a land, then I can go. If it is satisfying this condition, then I am making this visited array is true. Then I am adding this new coordinate row and column into this queue. Okay, now in the last step what I am doing, so after performing all these operations, so this grid will change, right? So based on this I am calculating the answer. So I have created one answer variable, and here I am checking if it is not yet visited, and if it is a 1, that grid is 1, then I am incrementing the count answer. Okay, and finally I am returning the answer. Okay, so the time complexity here is it is order of n cross m, and space complexity it is order of n cross m, but we are using q also, so it can be negligible. It is a very less space, but we are maintaining the visited array, so it should be n cross m. So this approach is for BFS. Okay, so I also wrote the DFS approach. So for the DFS approach, it is very simple. Just we need to do one thing. This DFS method. So I have created this DFS method. Okay, I have created this DFS method. So this DFS method we can call from here. Okay, we can call from here, and we can have visited array, and we can comment out all these things. Okay, we can comment out all these things, and we can uncomment this. Okay, so this is the DFS code. Okay, so similarly here also we are checking the boundary. If it is exceeding the boundary, and if it is already visited, and we are directly returning. Okay, if it is not visited, so we are making it to true, and we are going into 4 direction. Then we are calling again this DFS method. Okay, and finally we are checking, and we are calculating the answer. Okay, hope you understood this approach. Thank you for watching this video.